Alright, number 10. It says sells a certain shrub after 7 years of growth and shaping. The growth rate, so there's some kind of f prime of x going on there because of rate, during those 7 years is given by this. dH dt is equal to 1.5t plus 5. You can look at this as almost like y prime. So this is a derivative of some sort, and the in terms of variables are t. Okay? And we want to know the seedlings are 4 centimeters tall when planted at time is equal to 0. So you could say h of t is your position function. Because if I derive it, I'm going to have h prime of t, derive it again, h double prime of t, so on and so forth. Just remember that this is the same notation as what you have here. Okay? So the German Leibniz, as far as his notation when he was discovering calc or working with it, he chose to use differentials of dH dt. Okay? So Leibniz, where Newton used the h prime or the f prime of x. Okay? So in case you didn't know that. So we are here and we want to get to the position function, which is what we're looking for, h of t. Same thing that we did in the last problem. The only difference is just the notation. But we're still doing, we're still solving a particular, a differential equation, looking for that particular solution. All right, step 1. What do I do, guys? Anyone? We're going to take the antiderivative or take the integral of both sides in respect to t. This leaves us with h of t on the left, and we're going to see what we get here. So 1.5t dt plus the integral of dt. Notice how I constant multiple wrote out the coefficients. Anyone, what's the antiderivative of t? T squared over 2. What's the antiderivative of dt? T by itself. Okay, so I have t squared over 2. Since I have room, I'll write it the way I want you to do it. And what have I forgotten right now that I haven't written down yet? The constant multiple rule. So 1.5 and then 5. And last but not least, plus c. Guys, I'm doing it, but why am I doing this plus c? Why am I doing plus c on these? They're not definite. Nice. They are indefinite integrals that we're trying to solve for the position function. Definite integrals deal with displacement. Okay? They're between a and b. They're between two values, and those are numbers that you would normally see here. But this is not a definite integral. These are indefinite integrals that are trying to go back to the position function. We just have to solve for c. And then once we solve it, we have the position function. Okay? So the point that they give us is at time is equal to 0, it's 14 centimeters. So you can look at it like this right here. If t is 0, that's x is 0, then h of t would be 14. So what they're really giving us is, they're giving us that point of 0, 14. Okay? We're going to plug 0 in everywhere where we see a t, or that input variable, and we're going to plug in the 14, what this is all equal to. So we know this is h of t is equal to, what's 1.5 divided by 2? 0.75. So 0.75 t squared plus 5t plus c. This is what we got when we took the antiderivative. Again, we're plugging in 0 here and here, and then we're plugging in 14 here. I'll just do it color coordinated. So you have 0 plus c is 14, therefore c is what? 14. So it makes this general solution more particular, where the position function becomes the 0.75 t squared plus 5t plus the 14, and that's how you see that you get this answer right there. How tall are the shrubs when they are sold? Okay. So when they are sold, what do we do to get this 85.75 that they have? Yep, plug in T of 7 years. So they gave us after 7 years. So we're going to plug this into our position function to see how many or how tall would they be at that moment. There's another at moment. Okay? And you should get 85.75. Any questions?